Okay, good morning. This is just about the last section here of this unit. So it's about pH. You've already seen a couple videos on it. So here we are in the notes. So pH, instead of having to deal with such very small numbers, such as 10 to the negative 14. So as an actual number, this will look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's how many moles there are for every liter of hydrogen ions. So this is very cumbersome. So instead of doing that, scientists have figured out, you know what? We're going to use something in math called the log. We're going to use the negative log of it. So what do you get from this? That bracket means the concentration of hydrogen. So if the concentration of hydrogen is 1 times 10 to the negative 7, and the concentration of hydroxide, remember this is for an acid and this is for a base, is the same, that means a pH of 7. Because I take this number and I put a positive charge on it, and then I just use that raw number. So for water, they're equal, hence water is considered neutral. So when we have a pH scale, we know that water is neutral. And we should have a pH scale here somewhere. It's on the back of this. Okay. So what does that mean? Now, we don't have to worry about the logs. But one thing we should see is if the concentration of whatever it is, hydrogen in this case, is 1 times 10 to the negative 7, pH actually means that it has a pH of 7. Okay? Here's another concept that we should get. For acids, pH is less than 7. So even though the pH is getting smaller, it really means that the concentration of hydrogen ions is getting bigger. So here's the example. If I have 1 times 10 to the negative 6th, which is this number in decimals, it's actually bigger than 1 times 10 to the negative 7, which has 6 zeros and then a 1. Okay, so in other words, when the pH goes down, the concentration of hydrogen ions goes up, which means it's more acidic. And the opposite is true. If the pH goes up, that means the concentration of hydrogen ions goes down, which means it's less acidic, which also means it's more basic. So if pH is greater than 7, for bases, the pH is always going to be greater than 7. So that's from 7.01 all the way up through 14.0. So, can you figure out the pH for this? The concentration is 1 times 10 to the negative 3. So all I do is I take that number and put it in there, change the sign. How about the pH of this one? That's right, it's 11. So the pH is 11. So this one would be a base, and this one is a pretty strong acid. Okay? And the last concept we'll look at today is one thing to keep in mind. For every increase or decrease of pH of 1, actually means there's an increase or decrease in the concentration of a power of 10. For example, a change in pH from 2 to 3 is actually a tenfold decrease in the concentration of hydrogen ions. Okay, so 1 times 10 to the negative 2, that's 0.01. And then you compared it to pH of 3, which is 1 times 10 to the negative 3, that's 0.001. So if you saw these two, you should be able to see that the pH of 2, which is this one, has 10 times, oh, I should read this better, that's 5. So if we go from 2 to 5, that's going from 2 to to 3 to 4 to 5. So from 2 to 3 is 10. From 3 to 4 is multiplied by another 10, that's 100. And from 4 to 5 is another 10. So this is actually 1,000 times more hydrogen ions than 5. So when we go from 2 to 5, that means it's 1,000 times more acidic than a 2 is than a 5. And I've just shown this in chart form. So when you go from pH of 1 to pH of 2, it's 10 times less acidic. If I go from pH of 1 to a pH of 3, it's 100 times less acidic. If I go from 1 to 4, it's 1,000 times less acidic. Okay? Same thing going back. If I go from 2 to 1, that's a 10 times greater. From 3 to 2, it's also 10 times greater. Okay? So I'm going to also post the homework that was due for the last 2 days, and there won't be any homework for tonight, though. See you tomorrow.